All right, we have a line segment here that stretches from the point 0, 0 to the point 12, 9. We're trying to find the location of a point C that is exactly 7 units along that line segment away from point A. So what we're going to do here is we're first going to find the entire length of the line segment, and then we're going to find what fraction this 7 units is of the entire length. And then, once we know that, we're going to treat this like a vector and just find the coordinates of a vector that is that fraction of the original's length and pointing in the same direction, which is more complicated sounding than it actually is. Alright, so first let's find the length of this. Now, since it stretches from 0, 0 to 12, 9, this should be pretty easy because it's just going to be over 12 up 9 using the Pythagorean theorem. So let's see. Length of segment. So a squared, b squared, c squared, 12 squared, 9 squared, c squared. Let's see, 144, 81. And 144 and 81 is 225, and 225 square root of is 15. We're just kind of skipping straight there because we're running out of space. Right? So the entire length of this vector is 15 units. And then we have to find what fraction this is of the overall. And this is actually really easy. We'd say that AC over, I'm going to call this A and B equals, well, AC is 7, AB is 15, 7/15. So then, the vector (12, 9), if we want to find a vector that is 7/15 as long and points in the same direction, then we just multiply this by 7/15. So we'll call this AC. So let's see, 7 times, well, these are both divisible, but let's just use the calculator. We got 7, clear 7, ABC 15 times 12, 5 3/5, or 28/5. And 7 ABC 15 times 9, 4 1/5, which is 21/5. And so AC is this vector here, and since it's placed at the origin, that's also the coordinates for point C, 28/5, 21/5. So let's see if that looks reasonable. That was like 5 3/5, so 1, 2, 3, 4, 5, and a little bit more. 21/5 is 1, 2, 3, 4, and a little bit more, so it looks pretty reasonable. So again, the overall procedure was to find the entire length of the segment, and then entire length of the segment, and find out what fraction this length is of the entire, and that was pretty easy. And then to multiply this vector's components by that fraction to find out the components of a vector that is the shorter length and points in the same direction, and that happens to be the coordinates of that point. Now, if this wasn't starting at the 0, 0 here, then we could have also just written a pair of parametric equations and plugged that fraction in for our t value. We've done that before.